The circulation of water in the ocean can be divided into surface currents and deep currents, and today we will discuss surface currents in the Adriatic Sea. As a result of the interaction between air and water, wind drives surface currents on the surface. The study of Adriatic Sea circulation dates back to the 19th century. In 1887, Wolf and Luksch presented a schematic surface circulation of the Adriatic Sea only for the summer season. In the following years, Ferrolio, 1920, continued this effort, presenting more detailed information on the circulation of the Adriatic Sea. Our understanding of the circulation of the Adriatic Sea has improved in recent years thanks to a variety of accessible data. We can use satellite data to study surface circulations of the Adriatic Sea. Today, a large amount of observational data is collected daily, which is very helpful in understanding surface circulation. Simulations of surface circulations using computers have also enhanced our understanding of surface circulations in the Adriatic Sea. It is thus possible to discuss surface circulation in the Adriatic Sea with confidence and more detail. Three main factors can influence the Adriatic circulation. In the first instance, there would be river runoff, particularly from the Po River. Secondly, there is the atmosphere, which constantly interacts with the Adriatic Sea. The wind plays an important role in the surface circulation of the Adriatic Sea among the various atmospheric parameters. The current entering the Adriatic Sea through the Strait of Otranto is another important factor. Adriatic Sea currents are generally cyclonic or counterclockwise. There would be two components to this circulation: a weak and broad northwestward flow, Eastern Adriatic Current, and a coastally southeastward flow along the Italian coast, known as the Western Adriatic Current. Since a current entering the Adriatic Sea from the Strait of Otranto enters from the east, after traveling a considerable distance in the Adriatic Sea, it exits from the western part of the Strait of Otranto. Thus, looking at the entire flow path, we will see a cyclonic or counterclockwise flow pattern. Moreover, the surface current in every part of the Adriatic Sea is cyclonic or counterclockwise. We have another cyclonic current in the southern, northern, and middle Adriatic, which we refer to as gyres. In other words, the northern, middle, and southern gyres are the most important features of the Adriatic Sea surface current. Typically, gyres are extensive circulation systems caused by wind, thermohaline forces, or even topography. These gyres are controlled by bathymetry in the Adriatic Sea. The southern gyre of the Adriatic Sea is generally stronger than the northern and middle gyres. We review the typical speed of the current in three basins in the Adriatic Sea to gain an understanding of the flow velocity in the sea. In the southern Adriatic, the surface velocity of the current is approximately 40 centimeters per second. In the middle Adriatic, it is approximately 30 centimeters per second, and in the northern Adriatic, it is approximately 20 centimeters per second. Thus, we can mention that the mean surface velocity in the Adriatic Sea is 25 to 30 centimeters per second. The main question is the volume of water exchanging between the Adriatic Sea and the Ionian Sea. What do you think? The inflow of the Adriatic Sea from the eastern part of the Strait of Otranto is referred to as the inflow of the Adriatic Sea if the Adriatic Sea is considered as the main basin. The flow leaves from the Adriatic Sea to the Ionian Sea through the Strait of Otranto, which is considered to be the outflow. There is a seasonal variation in the amount of water entering the Adriatic Sea from the surface of the Otranto Strait. In the winter, the inflow from the Ionian Sea is approximately 0.153 Sverdrup, whereas, in the summer season, it is approximately 0.026 Sverdrup. This flow enters from the eastern part of the Otranto Strait. The outflow from the western part of the strait is approximately 0.057 Sverdrup in winter and 0.116 Sverdrup in summer. Sverdrup is a non-SI metric unit of volumetric flow rate in oceanography, with 1 Sverdrup equal to 1 million cubic meters per second. Consequently, three factors play a pivotal role in this water basin's circulation: flow discharge, winds, and weather conditions. The general circulation of the water in this basin is cyclonic, with a cyclonic cell in each basin named northern, middle, and southern gyres.